Peristalsis that is induced as soon as you think about food, or you're ready for food, or you put food into your stomach. That peristalsis moves quickly down the gut, causes the release of GLP-1, and all of you know the effects of GLP-1, so I'm not necessarily going to go through it, except to tell you that in effect, in type 2 diabetes, your glucagon doesn't go down, and your insulin secretory capacity is markedly inhibited, and that combination gives you your abnormality. I think I'm going to stop there and basically see if you can take questions. Otherwise, Dr. Macker is going to make me talk in a very high voice. So thank you very much for your attention. I'm sorry I couldn't complete the whole story. There's one more question there of some interest. Yes, sir. Well, yes and no. Remember that cats and dogs will get diabetes. That's right. That's right. But even it's not always prepared food. The point I think is, your point is well taken. It may be related to the type of food you eat. But I think the other thing that's most important is the fact that if you eat food, you have to burn it. And the fact is, we don't burn it. You want to eat 3,500 calories. That's okay. But remember, you've got to walk 35 miles. Because 100 calories is a mile. And the question is, do you walk 35 miles if you eat 3,500 calories? Now I know that some of that I'm exaggerating because most of us will have about 1,500 calories just for basal metabolics. But every time we exercise, remember, take a doctor for example. If you break down the doctor's energy utilization, let's say he is 150 pounds. He will require 1,500 calories for his 150 pounds. Then he walks around the hospital doing rounds. That's only worth about 300 calories. So a normal physician might only require 1,800 calories. Now, if he therefore goes ahead to have 2,400 calories but doesn't do anything more for the extra 600, that's going to become a pound a week that he puts on. Because 600 into 7 is just over 3,500 calories. 3,500 calories is a pound. So really, it's not what you eat, it's what you burn. If you can't burn what you eat, don't eat it. That's the whole issue. And I think that's why we need to understand. One of the points I make in my presentation is that exercise changes the muscle. The muscle at rest is very resistant to insulin. But once you start to work the muscle, it becomes insulin independent. It will pick up glucose independent of insulin. In fact, when you're jogging, your insulin levels go down, and yet your glucose utilization goes up. So once you exercise a muscle, you will cause greater disposition of glucose in muscle. I think it's very important to sort of keep that perspective in mind as we think about the pathophysiology of type 2 diabetes and how we treat it. We use drugs to improve sensitivity, metformin and the TZDs. We do drugs to cause insulin secretion, which would be the sulfonylureas, and nowadays the DPP-4s and the GLP-1, or we give insulin. But we always talk about diet and exercise, and we'll say, give the diet because you want to regulate how much you take in, but most importantly, you want to cause the disposition of the diet independent of insulin. And the only way to do that is by exercising the muscle. So to a certain extent, the idea behind this presentation was to try and target those so that we know that when we use medications or we use procedures, that's what we are trying to do. Thank you for your question.
How do you do IVGTT?
I'm sorry?
IVGTT, how do you do it?
How do you do an IVGTT? IVGTT used to be done a lot. It doesn't done much except in research processes. What you do is you give 50 grams of glucose intravenously, and what you see is the rate of decline of glucose. If you have the first phase of insulin secretion, you're able to secrete insulin right away, that first phase drop is very quick, and it's measured by a constant K. If you have a very steep drop, your first phase of insulin secretion is adequate. If your rate of drop is very slow, then you don't have a first phase of insulin secretion, you're dependent on your second phase of insulin secretion. In type 1 or in type 2 diabetes, that's the earliest manifestation of beta cell functional loss. You lose the first phase of insulin secretion. In all the studies that we do looking at early type 1 diabetes even, we'll do an IV glucose tolerance test to show the functional loss, and then we'll measure the anatomic loss by antibodies.
Constant monitoring is there in IV GTT. Or you do at fixed intervals blood glucose testing?
In type 2 diabetes, when we're not treating with insulin, we unfortunately are still doing blood tests every so often on a sporadic basis. Once you get them onto an insulin program, when there's a significant loss of beta cell secretory reserve, then you can use constant glucose monitoring. The options here are, while it is very good, ideally, cost really drives the thing. So right now in the US, I don't know about in India, in the US, for some reason, the insurance companies say you can only test once if you have diabetes and you're using pills. Only if you're using insulin can you test 3 times a day, which is ridiculous, but that's the way it is.
So, you have said that the insulin resistance is a differential phenomena. That means different organ is affected by insulin, means insulin resistance vary from organ to organ. So, and I think by the basic pathophysiology we know that insulin resistance vary not only organ to organ but also at post-receptor level.
Yes.
Like PI3 kinase pathway has different insulin sensitivity, and MAP kinase pathway has different, and GLUT4 has different. And so how you explain this differential nature of insulin resistance at post-receptor level? And I have also read somewhere that there is ethnic difference in insulin action, like Indians are not prone for water retention as far as insulin is concerned, while whites and other ethnic population are more prone for water retention with insulin action. So how you differentiate this thing with, means what is the action of insulin which is primarily differentiating these ethnic variation, and what is the difference which is differentiating at post-receptor level?
Let me first deal with the second part, which is the PPAR. The affinity of PPAR, there's no question that the reason for fluid retention, for example, is a PPAR gamma in the distal convoluted tubule. And the PPAR gamma in the distal convoluted tubule, if turned on, will cause retention of salt and water. That's why TZDs will usually turn on the development or the retention of salt and water. So the affinity of PPAR gamma is variable. Your expression is variable. I'm not sure I can tell you whether it's ethnically based or whether it's just based on the environment that your forefathers grew up in. And so I'm not sure I can give you a good enough reason, but I can tell you, yes, you're absolutely correct. There is a very clear difference of the affinity of the PPAR gamma to the or either the affinity or the amount of PPAR gamma that's available for turn-ons to occur. The second part of your question is even more difficult. There is no question. Now, once insulin binds to its receptor, it turns on about 5 or 6 different mechanisms. Only one of them we measure, which is glucose. Glucose is the only one we measure. We don't measure the MAP kinase. We don't measure the gene turn-ons that occurs with the movement of insulin substrate into the nucleus. And yes, there is no question that all of those are changed once you have insulin resistance. Whether there is an intrinsic defect that is measured between different peoples is not as yet clear. There is some evidence, as you said, that there might be a significant difference in intercellular receptors after insulin is bound to its receptor. But I'm not sure anyone's done some detailed studies as to why that occurs. Right now, the suggestion is that the longer you are living in a nutritionally deprived environment, the more likely you are to have post-receptor changes that change the action of insulin across all of its pathways. So that if you look at the Chinese, who also have a very deprived nutritional environment, and you look at the Indians, even though they do not necessarily share a common heritage, they tend to have a similar effect post-receptor. So we think it might be more environmental than gene. But if you told me that there was this specific gene that caused that problem, I'll give in to you, because right now I don't think it's clear as to what's driving it. But it's a very good question. Thank you.